Alright, so let's look at binomial now, which was chapter 14. So binomial, and it says it just here, I'll just repeat it, is for when the same trial is repeated however many times and there are two outcomes. Now, a few people ask me, isn't this just like a tree diagram? Yeah, it's exactly the same as a tree diagram, except imagine drawing a tree diagram with 100 trials. That's going to take you a long time and be really, really hard to work out what's going on with that. So that's why binomial can be better than your tree diagram. One thing though, it says there needs to be two outcomes. Now let's think about rolling a dice. If you roll a die, there's six outcomes, isn't there? One, two, three, four, five, or six. But you can make it two outcomes. So if you want to achieve maybe a result of a six, that would mean that six could be one of your outcomes, and the other outcome is not a six. Okay, so you can change it so something that might not seem binomial is binomial depending on what you want the success to be. All right, now this is our rule for binomial. Now I think this has been a little bit overwhelming for some people, particularly this bit, which we'll talk about over here, but I just want to kind of read through what's happening with it. So this bit here, this is just saying that we're working out the probability that the outcome, so big X, the outcome is X number of successes. So if this was a 1, what's the probability that we get 1 success? What's the probability that we get 2 successes? What's the probability that we get 3 successes? Okay, so X is the number of successes. Now, when we're repeating trials, the probability of success each trial is going to be the same because you're doing the exact same thing. So the probability of success is P, and we'd put that just in there, and you'll see that there's a P here as well. N is the number of trials. So if we're using that dice example, if we're rolling a dice 50 times, our N's going to be 50. If we're rolling that dice 20 times, our N's going to be 20. Okay, so these are the three things that you need to find out what they are, and all we're really doing is plugging them into our formula here. Now, I'm going to talk about this bit in a second, but basically what we're doing is this is the chance of success to the power of however many successes you want times the probability of failure, so that's why it's 1 minus P, times the amount of failures that you want. Okay, now both of these two are always going to add up to N. Right? Now this bit here, this is combinations, and we did look at this last year, but I think a lot of you are still a bit fuzzy with it. If you know how to do it, great. I'm going to talk about some common ones later, but I want you to look at this bit here. Okay, so these three things are the exact same. Okay, now even if you don't understand what this even means, that's actually fine. If you remember this formula, you're going to be able to work out the answer every single time. You're going to have your CAS for this SAC anyway, so I wouldn't even worry too much about it. That's how you do it with your CAS, okay, NCR, and I might show you that pretty soon. Now what it actually means, this bit here, the amount of ways you can choose X number of objects, X is there, from N number of objects. Okay, now let's do a bit of an example down here. So let's just say you've got no idea what this means. Doesn't matter. We've got this rule here. So let's substitute each of our values in. So our N is 5 and our X is 2. So that's going to be 5 factorial N minus X, so that's 3 factorial times 2 factorial. Now hopefully we can remember what factorial is. If you've got 5 factorial like we do up the top, that just means 5 times 4 times 3 times 2 times 1. Okay, if it was 100 factorial, it would be 100 times 99 times 98 all the way down to 1. Alright, so let's actually work out what this is. So you can write them all out if you like that. It might make it a bit easier for you if you're not really sure what you're doing, because then you can start to cancel things out. So we can see that we've got a 3 cancelled, we've got a 2 cancelled, we've got a 1 cancelled. 2 times 1 is just 2 anyway, so let's get rid of that. So we can see we've got 20 on 2, so the answer would be 10. So 5 choose 2, the answer is 10. Now I'm going to do this again. Instead of writing all of them out, I can see I've got a 3 factorial down the bottom, a 2 factorial down the bottom as well. 5 factorial is the same as 5 times 4 times 3 factorial, because that means 3 times 2 times 1. Can you see how that's down the bottom and the top? So cancel that out, cancel that out. That's going to be 2. See how it's 10? Alright, now let's go to this section here. This is what you might see sometimes. Okay, these ones are going to be common. Now let's think about each of these. So we've got n number of objects. We don't know how many objects, but we've got n number of them, and we need to choose 0 of them. So you need to choose 0. There's only one way that you can choose 0, isn't it? And that's to choose nothing. So the answer to that is actually 1. Now that might be a little bit hard to understand, that kind of scenario, because it's choosing nothing is sort of hard to get through your head. If you can just remember that n0 is 1, you'll be all good. Let's go to the next one. You've got n number of objects, we don't know how many, and you need to choose one of them. How many ways can you do that? Well, you can choose, like an option is just to choose any one of those n. Okay, so if you had 100 up there, you'd have 100 ways. If you had 50 up there, you'd have 50 ways if you're choosing one. So if you've got anything up the top and 1 down the bottom, the answer is what's up the top. So that's why that's n. And again, if you don't understand what I'm talking about, if you can remember that, you're going to be all good. Now, with binomial, you can get your expected value, which means the same as the mean, and standard deviation as well. I'm going to come back to this. So I'm going to leave this for now. We're just going to do some more basic examples to start with. You are going to have access to your CAS for this SAC, and when you do the second exam as well. So it is important that we can use our CAS to do this quickly, except something commonly happens where multiple choice questions can be a little bit tricky, and they might not necessarily give you the end answer. They might give you a range of options that are kind of halfway to getting the end answer. So that's why it's important that that we know how to use the formula and can actually write the formula down rather than going straight to our CAS. Right, so let's look at this example. If a soccer player has a probability of 4/5 of scoring a goal and has 20 attempts at scoring, find the expected value and variance of this binomial distribution. I'm going to go back to this one. Our expected value and variance and standard deviation were here. I might leave that one for now. Alright, we want the probability of scoring exactly 15 goals. Okay, let's work out our n, x, and p values. Now remember, n was the number of trials that you're having, the number of times you were repeating it. So this person was having 20 attempts. So our n would be 20. The next thing, what's the probability of success? We can see that they've got a probability of 4/5 of scoring a goal. So our p is going to be 4/5. Now the next part, we need our x value. Right, now that's how many successes that we're having. Now it's told us that find the probability of scoring exactly 15 goals. So that would mean 15 successes. So our x is going to be 15. So all we need to do is use these numbers in our formula. So the probability that the number of successes, or that the outcome is 15 successes, would be, out of the 20, we've got 15 successes, and x times the probability of success, which is 4/5, and we were having 15 successes, times the probability of failure, which is 1/5, and we were going to end up having 5 failures. Now you could enter that straight into your CAS, but it's important that you can get to this step here. Okay, now some of these you will be able to do by hand, some real simple ones. With this one I might just enter it into my CAS though. For this next one, it's asked to find the probability of scoring more than one goal. So that would mean 2 goals or 3 goals or 4 goals or 5 goals all the way up to 20. So there's a heap of things we'd have to work out for that. And we could do it that way and add all those probabilities together, but it's going to take a long time. Something that's going to help us here is we know that all probabilities added together add up to 1. So we're after the probability of scoring more than 1. Now, as I said before, we could do 2 plus 3 plus 4 plus 5, but I can make that shorter. If they all add to 1, we can start with 1, and we can just take away the things that we don't want. So we don't want the probability of 0, and we don't want the probability of 1. Everything else we do want. Now we can work out both of these things the exact same way as we worked that one out. So let's really quickly do that. Alright, so the probability of getting 0 successes. 20 trials, 0 successes, times the probability of success, which is 4/5, times the number of successes, which is 0, times number of chance of failure, which is 1/5, number of failures is 20. Cool, so we've done that one. Now we need to do this one. Cool, there's that one as well. You can enter this into your CAS, but these two things here, they're some of the ones that we can do reasonably quickly. So I'm going to do those ones now just so you can see. Alright, now 20 choose 0. There's only one way you can choose 0, so that's a 1. Anything to the power of 0 is 1. And then we've got 1/5 times 20. Now over here, we've got 20 things to choose from. We're going to choose one of them. How many ways can we do that? It's going to be 20. So if ever there's a 1 down the bottom, your answer is whatever number's up top. Times 4/5, so you can put those together, times 1/5 to the power of 19. Again, you can put that straight into your CAS, but it's important that we can get down to these kind of things like that. I'm going to move over to my CAS now, just so we're really aware of how to go straight to our CAS and do things really quickly, because it did take a little bit of time to do this, didn't it? We can probably be faster than that.
Right, so we're doing B using our CAS. Find the probability of scoring exactly 15 goals. We already know this is binomial, so I'm going to go menu, probability, distributions. We'll look for binomial. We can see there's 2 binomials here, binomial PDF and binomial CDF. Binomial PDF is when you're after the probability of one specific outcome. So we're after the probability of 15 successes exactly. So we're going to choose binomial PDF. The number of trials we're having was 20. Enter that. Probability of success was 4/5. Enter that. And we want 15 successes. So 15. There we go. There's our answer. See how fast that was? Now let's have a look at C. So find the probability of scoring more than one goal. Let's go to menu, probability, distributions. Let's look at these two again. It wants more than one goal. So that would mean, if we're having 20 trials, that would mean 20, that would mean 2 all the way to 20. So that's a span, cumulative. So we're going to the binomial CDF. Alright, now we're having 20 trials. Chance of success is 4/5. Our lower bound, go away. Our lower bound is 2. And our upper bound is going to be 20. There we go. How easy was that? And how fast was that too?
So there's the answers from our CAS for those previous 2 questions. The next thing I want to have a look at, a lot of people have asked me about, there's been a few problems or troubles when trying to answer questions like this, where we've got to find the number of trials or find what n is. So here's an example. Hopefully going through this, I'll touch on a few of the things that people are having trouble with. Alright, so Jeff has determined that his probability of hitting a 4 off, that should be FF, any ball when playing cricket is 0.07. What is the fewest number of balls he must face to ensure that the probability of hitting more than one 4 is more than 0.8. Now let's just quickly look at something. Hitting a 4, like these are numbers, except they've got nothing to do with the problem really. It's just success. Success is hitting the 4. Failure is not hitting the 4. All right, so 4 is not going to be in your sum anywhere. All right, it's a little bit of a tricky sort of thing that you might have to get your head around sometimes. Okay, now we've been told what the probability of success is, which is 0.7, but we're trying to find the fewest number of balls he must face to ensure that the probability of hitting more than 1 4 is more than 0.8. So we want the probability of more than one success, more than 1 4, to be greater than 0.8. This is where we start, and we have to go from here. Now, this is sort of similar to before. We don't know how many trials we're doing. That's what we're trying to find out. The probability of greater than 1, that would mean 2 and 3 and 4 and 5 and 6 and so on. There's no end to that. We can't write all of those out, but we can sort of do it the opposite way. So we can have our 1 and take away everything that we don't want. So if we want greater than 1, that means we don't want 0. And we don't want 1 either. All right. Now you might have thought before, yeah, we haven't been given an n value, that's fine because we're trying to find the n, but we haven't been given any x values either. These are the x values here. Okay, now we can put together sums for these, or put all the numbers into the equation. So 1 minus, now this here, we don't know what n is, so number of trials n, number of successes is 0. The probability of success was 0.07, we're having 0 successes. Probability of failure must be 0.93, and we're having n number of failures. We've just finished that bit, we're done there. We now need to look at this one. Alright, so the probability of 1 success, we don't know how many trials we're doing, so n. We want 1 success. Probability of success is 0.07. We're having 1 of them. Probability of failure is 0.93. We're having n minus 1 of them because 1's already been used there. And that is greater than 0.8. So I've got a reasonable length sum here. Now you could just put this straight into your CAS and solve for n, because that's what we want the value for. I'm going to do one more step though, just in case, or just so you see a multiple choice question where you've got to kind of go the next step. Right, so n choose 0, that's 1. Anything that pairs 0 is 1. N things to choose from, you're going to choose 1, so that's n. There we go. We can get rid of a few of these numbers here. Okay, now let's just use our CAS. We could have done it all the way up here, but that looks a little bit more simple for us, I hope. Now, if you're using your CAS, remember we're just trying to find out what n is. So you're going to use your solve function. You're going to tell it you're solving for n. Once you've entered that into your CAS, you might have to end up doing the approximate, so press second and then enter again. And it should give you n equals negative 12.18 and then equals 41.77. Now, when I put this in and I used the greater than symbol, it didn't work for me. So what I did was I changed that to an equals. For some reason, the CAS doesn't like the greater than or less than symbol, so I changed it. So this would actually have to be, this would end up being greater than 41.77. Now you can't have a negative number of trials, can you? So let's just forget about that one. That one's no good. Right. Now, this has been a problem. I've had a lot of questions about this. Yeah, we can't have 41.77 trials, can we? We can only have a full number of trials. But do we round up or do we round down? Now let's look at what we've actually been asked here. What is the fewest number of balls he must face? So we've just found the fewest number of balls, which is 41.77. So if we round down, that would mean 41 balls, but that's less than the fewest amount that we can have. So we have to round up. So we'd say, therefore, he has to face 42 balls. And we're done with that one. So earlier I skipped the part talking about the expected value or the mean and the variance or standard deviation of a binomial, but I'm going to come back to that right now. We normally think about standard deviation and mean and think normal distribution, but binomial distribution has a mean and a standard deviation as well. So we need to know how to get those two things. Now there's a couple of rules. The mean, now they use expected value sometimes, but expected value is the same as the mean. To find that for binomial, it's just n times p. Okay. Now for the standard deviation, that's going to be np times 1 minus p, and then square root over the top as well. And remember, standard deviation is the square root of variance. Okay. All right. Now we're going to use these two rules to help us out here. All right. Now let's read through the question. Let x be a discrete random variable with a binomial distribution. The mean of x is 3.2 and the standard deviation is 0.8. The value of n, the number of independent trials, and p, the probability of success in each trial are. All right, so we need to find n and p, and these are the possibilities that we've got. We've got a couple of rules here that have n and p in them. I'm going to plug them in. All right, so we've been told that the mean's 3.2, so that means we've got 3.2 equals np. And we've been told that the standard deviation is 0.8. So we've also got 0.8 equals this. Okay. Now, honestly, you could just put this straight into your CAS, solve system of equations, and work out what n and p are. That'd be super fast, and you should probably do that. I'm going to really quickly do it by hand because I don't want to switch between my computer. It's going to take too long. All right, so np can go straight into there. We'll square both sides to get rid of that. Let's get this 3.2 out of there. Uh, 0.64 divided by 3.2 is 1/5. So P is equal to 4 on 5, which is 0.8. If I look up here at the answers, there's only one with a p-value of 0.8, so I'm thinking it's B. So you could just circle B if you're real confident. I'm going to just check that I'm right. I want to make sure that n is 4. So if I've got the p-value, I've got a rule over here, or this one here is going to help me find what n is. And that is 4. So we're right, the answer is B.